Why did you choose to put the Hummingbird sensor in front of John's company, HyPoint? Why did you think that would be a good fit?
It was a good fit for multiple reasons. One, and this is typical with a lot of applications, right? It comes down to size, point cloud density, data accuracy, and then also ultimately cost, right? And HighPoint was in this transition phase where one sensor was being obsoleted from another manufacturer. They needed something that was going to replace it. And Seyond was coming out with the Hummingbird. We decided to put it in front of High Point. We got them a unit for testing, and Mitch and John tested it and was like, "This is it." So maybe I'll kick it over to John.
When we got the sensor in the Hummingbird, we quickly realized not only would it replace this application, we actually can use this for these other applications we're doing, and was really excited about all the same things, the same form factor. When we're putting things on the side of the road, we're trying to make it very efficient and easy to mount. The power requirements fit right in what we were already doing, so quickly we could swap out the other sensor we were doing and put it in, and the cost was extremely competitive for us to be able to use and be right back, not having to raise costs, in fact, being even more cost competitive than the sensor we were using before.
As you guys were testing the Hummingbird, how were you guys able to maybe find other uses for that other than just what we originally thought it was going to be as a replacement for the obsolete sensor?
Yeah, we had other sensors that we were using already or testing for these other applications. A lot of times we're testing these other sensors because of the cost. Like the other sensor we were previously using was just too expensive for these other applications. So when we got the Hummingbird in, like we said, not only was it satisfying the one we needed, which was for the overheight detection and vehicle classification, because of the cost competitiveness, we could start using for other applications like wrong way detection,
Mm.
going truck parking and analytics, some traffic analytics, speed and lane monitoring. So we started like, wait a minute, this is for us to be able to build a platform or these other applications around a single sensor with a single partner. It's a big advantage for us.
There were a lot of question marks for quite a few years when an application was being presented to whoever it may be, especially if you're talking about DOTs. That one of their big concerns is like, look, this sensor has to survive and live in the elements. And there was a lot of question marks when it came to spinning technology because, over time it does get beaten down. That's just the basic of it. That's the basic principles of the spinning technology. And solid
Mm.
state offers a much more robust option, especially in those environments.
Well, Xeon did a great job in designing that unit. I mean, you put a Hummingbird in your hand, you know that that thing is going to survive a beating. And I know, John, you guys put it into your own housing and utilize it in a different way and make it even more environmentally hardened. But that Hummingbird on its own is a beast. Like you can put it on an AMR, you can put it on an end effector on a robot or out in the elements, right? What John's doing.